I've just uploaded my learning version of Qwak. I've seen a few people kind of posting they're working on games and asking general games questions. And I figured since I have a complete game just sitting here, I could easily port it across. Something that's sort of more fully featured. It has an entity system, it has a collision system, it has hooks in for audio, although obviously there is no audio in this version because you can't just magically port a seed across. It has sprites, it has animation, it has levels. I load a graphics file into VRAM assembly. There's text printing, there's number conversion, there's a password system, interludes, different graphical formats, but ultimately it is just a rough Commodore 64 port. There's a few issues with it, which I'm sort of going to talk about and cover in this. Give a quick demo of the game. It uses the NESPAD. The right select's not that it makes any difference in this version. A to shoot a little bubble. B you can jump or you can press up. And you have to collect all the keys. Opens up the door. Come on, come on, come on, come on. That's the level password. The instant thing you'll note is the huge area at the bottom. This is because the Vera has a higher vertical resolution than the 64 does. I mean, normally you would cover that up again with something black, but for learning purposes, I've left it so you can kind of see what's happening. Another thing is, as soon as you hit the above 0, you'll see sprite instantly disappears. This is because the very top line is 0, and I only have an 8-bit Y coordinate in my system. Because in the 64 you had 50 pixels above it. It was fine. So obviously to go above the top, I would have to set the YMSB to be 3, which would require some serious modifications to the code. Handy thing though is I was able to completely get rid of the XMSB, because the very side pixel here is 0, there's no border, and 32 chars across, dead on 256. All of that horribleness went away. I was also fortunate that the sprites don't use black. I don't have to worry about the transparency problem. Here's one of the bosses. Get that, you can float. Get the shield, you're supposed to be flashing, but that requires color changing, which is very difficult. And then you can bounce on top of the boss. The boss would normally flash. Again, very difficult in this version. That's basically all there is to it. I mean, there's a bunch of different enemy types, but that's, for all intents and purposes, the game. We'll come back to it later. So the code. I recommend relaunch 64. It's written in Java. It's open source. It's got a few idiosyncrasies to it. It also is a little bit broken. Some aspects. It's a bit abandoned. But it does the job well. It supports a bunch of assemblers. And it gives you autocomplete, which is always handy. And it has this go to label, so you can quickly type in a label and search to it and jump through your code a lot quicker, which is nice once you get used to it. So general layout, I've tried to keep my macro usage to an absolute minimal. I don't think macros are very good for beginners, and especially if you're trying to look at my code and understand how something is done, having a bunch of it hidden behind some macro you have to go and find in another file is not very helpful. Also, this is one gigantic monolithic file. There is a separate structs file, which isn't really that useful and important to things. Again, when you are trying to learn something and you go, oh, this guy does this, and oh, it calls this function. Where's that function? Then you start playing whack-a-mole through all the different files to find that function, and then it calls another function, so you go and play whack-a-mole again, and then you forget where you were. You just quickly get somewhere that's got a function so I can show you. So if you click on a function and you press Control F12, it will jump straight to that function, and you press Shift F12 to go back. Kind of handy if you're trying to read through and follow some of my code to figure out how I did something. So the macros I have done, there's the call table. Yes, the 65CO2 has the wonderful jump place, X. However, a lot of my code is to preserve X across the jump, and I use Y. So instead of rewriting all of that code, I've just left the push and RTS version before. Making tables, not very interesting. It just tidies it up a bit. And high-low words. This is just a struct so I can declare a word and I can then access the low and high of it. It just makes it easier to read. The font encoding of Qwak is completely custom. This just ports for us. Then have a gigantic pile of constants, all magic sprite values, movements, entity numbers, health points, jump speeds, tiles, intermission times, colors, all the Vera registers. Now, speaking of the Vera, I really didn't want to get into super kooky, custom, high-end TAS magic, but the Vera broke me. Now, I know I've made a video on how ports suck. After going through and changing 2 lines of code into a giant pile of port code, let me just reiterate, they really suck. So, instead of writing out the code to set the ports values every single time, I've made this handy little macro for me. If you're not versed in 64 TAS, probably don't try and understand it. Just understand that I can add an address to this macro. It's called a segment. They're like macros, kind of special kooky magic again. But I can add an address and it will look up to make sure it hasn't already used an address. If it has used the address, it will give me the index of the previous added one. If not, it'll add it and give me the index. And this way allows me to just collate every single Vera address I want into one list. Then I just load X with a number and jump to a routine. It tidies up quite nicely, but it's a bit of TAS voodoo. And if you're not using TAS, using something else, you probably won't be able to use it or make a version of it. I just got fed up with it. I also have some convenient functions just to convert a COM64 number into a Vera number, or an X and Y position into the Vera position. They're just, simple little tidy things, nothing to really worry about. And these are the Vera, the CX16 defines. Get joy, and joy 1, which is actually at O2BC, not O2BB, like the docs say it is. Anyway. And that is a horrible spelling of region. I now notice that now. So I have all my 0-page variables. Bunch of generic temps, bunch of pointers, collision. So we have this at 7F because we're on the CX16. I've decided to put variables in the upper RAM bank. Typically I start them at about 200, but obviously because we have the kernel and basic running and Vera uses key tables and other kind of things below 800 for safety, I've just shifted them all up into the upper RAM bank. I have plenty of room. Joysticks, the game data, level data, player data, passwords. You see MPlex, it stands for multiplexer. Obviously in the C64 version I had an up to 32 sprite multiplexer in it. Completely unnecessary, completely ripped out in the CX16 version, but the names in files, it is in the file everywhere, so I've kept MPlex. It just stands for multiplexer. I basically use it in this to store, sort of cache all the sprite data. So we update all the sprites, and then in the IRQ, it blats the sprites across to the Vera. The current map is just stored with the data is encoded and compressed. I have to fit it in 16K. So as when you start a level, it just pulls out the level, converts it into an actual map, just stores it there. Couple of cheeky helper macros just to shift the X2 by 2. This is because the first sprite is reserved for the player, the second sprite is reserved for the bullet, or the egg, those. Then from the third sprite onwards is reserved for entities. So whenever I have entity code, I always offset it by 2. But the collision systems take X from 0 range. So when I need to do collision with an entity, I need to shift X forward by 2 and then back by 2 to convert from full sprites down to entity sprites for various functions. It should mostly make sense when you see it in the code. Okay, so my VRAM map. The title screen is in chars, and so I had to keep in chars because I need to do CRAM color scrolls and stuff like that. And so I have dedicated a single screen to be the title screen. In the C64 version, it uses the same screen and it'll clear and redraw each time. In this version, I just have, there's always a title screen sitting at the beginning of VRAM. Game screen is in the next screen in VRAM. At 2000, I have the font, which is the 1-bit char version of the font. It actually starts at char 128, historic reasons. Then the game chars start at 2600, and they're in 4-bit version. They're in 4 bits per pixel. And they use the Commodore 64 colors. I haven't done anything fancy. I haven't redrawn the graphics at all. I've just done a great one-to-one conversion. There's a Python script that does it. Then the sprites, they're not listed in the VRAM map, but the sprites occupy the entire upper 64K. I'll show that in a minute. This is just a collection of copy fields. It's all the stuff I need to blat into VRAM at the start, i.e. the font, the fixtures, the upper fixtures, and the 4-bit plain font. I also need to show the font for, say, game over and the password and a couple other things. So I have to have 2 versions of the font in memory because it needs 2 different graphic modes. So much fun. So wait, how does that work? Oh, that goes to 80D. Okay, so code start 01, standard, basic. Also, fun fact, important to note, that the basic text has to be in the screen encoding. And if you redefine it such as I have for Qwak and you don't have it in screen encoding, your basic code will just be random gibberish and it'll make no sense to anything. And it's fun to track that one down. So just be aware, you must keep your encoding for this green. Then change it. This is the startup code. The thing with the sprite file is it is just so big, it is literally 64K itself. So it's an external file that I reload into the upper bank of VeraRAM at the start. So this is just set LFSS, set name, do the vload. Off we go. After this, I then disable all interrupts, because the interrupt actually modifies and deals with Vera. I have to disable it when I interact with Vera, otherwise the ports will trash each other. Then I copy in all the Vera data that's stored inside this PRG. And then I set up the mode, so I want 320 by 200 mode, just to keep it the same as the C64. Actually not by 200, but you know what I mean. I then clear all the variables. I then, because the title screen is constantly sitting in RAM, I just set it up once. So I empty it and then I plot all the strings on it. I then go in and initialize all my sprites. So let's just flip to the sprites. Turn the grid off. Okay, so originally when I thought of doing this, I thought, oh, this would be great, because the sprites are all 16 by 16. Only they're not all 16 by 16. They're mostly 16 by 16. So all of these, all the top row and the second row there, for example, crack is 16 by 16. All the enemies, the purple enemy is 16 by 16. But if you look at the angel death one, it's actually 16 by 21. And the other flapping one is a bit wider. Then if we get down to the Qwak or the bubbles or the boss sprites, they're all 24 by 21. So in order to just get this to work, I've cheated and everything's just a 32 by 32 sprite. There's 128 sprites, so that eats 64K. Given the original game had a limit of 16K, it's kind of hilarious, but it just simplifies things. Also, I've left the mirrored images in the sprites, although the Vera does have hardware mirroring. The code is not designed to really store or understand that concept. And to add it would be some significant rewriting part of it. So I've just left mirrored in as well. You could easily put mirroring and cut this down to, I don't know, 40K maybe, 42K maybe. Likewise, instead of having 4 sprites for the bosses, you could easily combine them into one and make it one 64 by 64 sprite. It would simplify things, but my code is already written around and designed to have 4, so I've left it at 4. This is just setting all my sprites to on top of everything, not flipped, 32 by 32 palette 0, because they're on 64 colors. I set every single sprite way off the side of the screen, just in case something else has put a sprite on or been left over with the reset routine, for example, doesn't reset things properly. Just make sure they're off. And then I enable them. And then I enable the IRQs. So from this point on, whenever I want to touch Vera, I have to disable the interrupts. I just do an SEI CLI. It's a bit hacky. It's not the best way of doing it. It was simple and it works for this example. If I was playing music though, it might cause problems and I might need to switch to something that enables and disables sprite blatting. And then we do the initial setup. So this is the main loop. We wait for LSBTOD. I have no idea what that stood for. Can't remember. Basically, it has the IRQ done. then it increments this number. So it waits for the interrupt. It doesn't do a WAI because I kind of want the interrupt to still happen. And then it jumps to whatever game state pointer is, which varies. So this is the main game loop. I'll just scroll down past this for a moment. There's the intermission loop, game over loop, and the title screen loop. That's where we start. We start with the title screen. So again, we instantly go into a jump table. I use the FSM inside FSM methods for this. So we clear the sprites, clear this entry. I switch the Vera over to displaying the title screen and the title screen format, and I make sure that it's got the right char sets. I clear HMV scroll while I'm there. I turn off layer 1 just in case. I install the sprites for the Qwak text, so they're actually sprites up the top. Reset everything. Clear the player's data and state. And then I just sit around and I scan the joystick. And then I animate the rolling text colors, depending on what you selected. Check for you entering a password or a cheat code. This is all fairly straightforward stuff. Until you press fire. And then once we press fire, we get into the start game. We transition to the main game loop. Setup, act, dissolve, and fruit chars. This is something, again, I've gone and simplified. So the in-game chars have this, which is the fixed char. So the launcher, the spike, the key, the door, the flower, various pickups. They're the same in every single screen, despite the fact its backgrounds change. But we have 4 different background filling tiles. Then there's the drop shadow tiles, which are unique. There's the 4 different main platforms, which then dissolve. And then each one has a unique fruit. So on the C64 version, due to memory constraints to keep the actual original boot file down, I would dynamically generate these. I'd dynamically generate the shadow tiles at the start there from the first 4 tiles, and I would dynamically generate the dissolve version of the block, which has got a simple pattern that it just shifts up. I have completely got rid of that system for this version because masking and doing pixels like this on the C64 is not very hard. It's quite easy, in fact. Doing it on 4BBP through the Vero, through ports, it's a bit of a pain. And I didn't think it was really going to help you understand anything. So I've just blown through RAM. I just have 4 giant pre-built sets that I blat into Vera RAM. I need them. Just a simplification for learning purposes. Which is what that function does. It just looks up which one of those 4 I want, indexes in just as a straight VRAM copy. Clear all the sprites. That just sets them off to the screen. I draw the status area on the left side of the screen. Then I switch this to using the screen for the game. So the game screen, the game chars. I change the mode. We switch to mode 3, for example. Current copies. More plotting. I set the lives. I tell the player to appear. Start playing music. We had it. And then we get up here to game loop. So we have the player appears. We have the player moving normally. Player exits the level. And we have the player is dead states. So the appear is where I build the level. I apply shadows to it. They're dynamically added because, again, having a map that didn't have all the little tiles in it allowed me to focus on 16 by 16 tiles and saved me a lot of RAM. Don't look at that function. Don't try and understand it. It is just madness. It's just building a soul drop shadow. Don't waste your time trying to understand it. Just accept that it makes it look better. That's all you need to know. We draw the tile map to the screen, set the plate to the spawn point, we unpack the entity bytes, again, with they're compressed a bit, and set up all the entity sprites ready to go, and then we transition to the plain normal. So it builds its collision table. The collision system in this is not the best. It was written for size rather than being good. Another trick is originally until about a week before the deadline, everything moved half the speed it did, and the collision system was fine for that speed. But then Soul was like, you do realize everything in this game is supposed to be moving twice as fast as it is now, right? I was like, no. You could have told me 4 months ago when I did the first version with something moving on the screen. No, I found out a week before the deadline. So things just got doubled, except for the springy things. Having something that can move at 14 pixels per frame, the collision system just cannot handle it at all. So they still move slowly. That's why they kind of float around. But, does the job. Good starting point. Gets you going. There's a lot of boss code that were literally hacked in 2 weeks, 2.5 weeks before the deadline. So code's a bit rough and ready. Here's an interesting. It's really easy to do keyboard scanning and interact with the kernel. Normally in the C64 version, I have pulled out the kernel and I have completely trashed all of the 0 page, all of 200 and all of 300, and you got to do lots of rescuing and it's pain. On the CX16, because the kernel is always there, we always have to sort of bow to it and keep everything kernel safe. So you can just call kernel functions. Because I don't let the normal kernel fire, it jumps into my routine and then I pull everything off and do an RTI. I have to manually call scan key before saying get in. On this one, if you enter the password level skip, Z key skips. You can't detect the Commodore key or CX key in this case with get in. There's no ASCII code for a Commodore key. Weirdly enough. That just, tells the level its exit and transitions. So we do a bunch of delta checks. Here's the shield flash code. You can see I just toggle between 2 colors, which is so simple to do on a C64. Kind of pain. What I'd have to do is duplicate the first palette into the second range, set the player sprites to be the second palette, and then directly modify the yellow in it. It's doable. I just didn't think it was really worth it for example. Oh, another thing is, if you see these, the G form, typically you have, B&E, BEQ, BCC, BCS, and because we're on the 65CO2, BRA. TAS has the G form. And what that does is, if something is in range, it will use the branch version, and if not, it'll invert the branch, jump over, and then do a jump. Or in the case of BRA, it'll either put a BRA or a jump, depending on how far something is. So you never get that, I'm sorry, this branch is out of range too far by 2 bytes. Pain. It just disappears. The player exit, this is when you've collided with the door. We just play the little animation, switch to the interlude, and then when you die, we play the hurt sound effect, do the death animation. transition to title screen again. End of game loop. This is where the big magic happens. Everything before this is basically the player code. And this is where we update the bullet, update the entities, update the bubbles, and animate the door. Then we just go back to the main loop. Intermission. I mean, there's not much to it. We plot the level, we generate and plot the password. We make the player walk along. There's a bunch of hideous self-modifying code to animate the two doors. Which when I originally wrote the code, I didn't think about the intermission, and it's like, oh, I have to have two doors on the screen at once. Yeah. Oh yeah, bunch of horrible self-mod code. Game over. It just prints game over. Waits for a press. Not much to it that one. And so, starting the level just goes through and prints things. Add X with MSB and clip. This is an interesting function. Much simplified on the CX16 because I don't have to do fancy 9-bit maths. But the important thing is, even though the screen is 256 wide, it doesn't wrap around. So this function here is just to make sure that when you say go left or go right, you hit the boundaries and you stop at them. And I just basically check to see if you're in a large safe area. I just return straight away, no problems. But then if you're in that sort of area, I can then detect if you suddenly get a very big number, if you suddenly get a very small number, and then I know you've clipped, you've wrapped around, and then to clip it back to the right one. When you don't have to do 9-bit maths, so much nicer. Joy to player delta. This is sort of the magic function that decides what the character does based upon your joystick input. You'll see there's still a lot of byte.2Cs. This is a bit skip trick. Again, it was a 16K cut. Anything I could do to save space was used. So in this you have moving left and right. The player accelerates, so I have a slow move initially, and then you speed up as you move across. Just add some more dynamicism to it. The jump method is a linear accumulation that kind of gives you a parabola. So you have acceleration and velocity, but you can kind of just add a single number to it, and that gives you a sort of parabola that you can easily early out on. Fairly standard technique. If you're falling, you can collect a pickup that lets you hover. So if you keep holding up, you can kind of Princess Peach flap your wings for a bit. So you'll see some code in here that detects and handles that. Here's the jump code. Start the jump. So when you stop pressing up, I instantly take you to the top of the curve. You start falling. You kind of still carry on up a little bit afterwards. Yeah, this is the flap mess is in here. Don't start floating, stop floating. If you hit your head, you can't float, etc. On ground status is pretty important. You need to know if you're on ground, so you can't jump in midair, etc. This handles the Y acceleration for the jump. Just sets play animation. Yeah, that was fun as well. So setting the sprite frames. Obviously in the C64, you just tell it the number of the sprite you want. A nice simple byte. It works. The Vera, you have to give an explicit pointer, which is then also, shifted by 4. So it's 24-bit, but it's shifted. So certain things like move to the next frame is just ink 2048 or whatever. Not on the Vera, it's not. So I get the sprite number and I have to times it by 16, 16-bit maths, obviously, and then or 8 puts it into the upper 64K. I have 3 of these functions. In an ideal world, you wouldn't really have 3 of these functions, but just to save me from having to do X shifts and manipulations, I've just made 3. One for the player, one for the bullet, and then one for entities. But ultimately, in an ideal world, you would consolidate all those into just one function. Animation code, nothing fancy, just increments a frame count, and once it gets to the end, adds it to the base, and then gets a bunch of, jump tables, movement deltas, etc. Here, the sprites, remove any pickups. The bullet logic just spawns it where you are, it bounces around the room. Pretty straightforward stuff. There's the custom bullet setup. Boss code, which you can, if you have the shield, you can mount on top of the boss. So I have to handle the fact you've collided with something. Have you collided with a boss? Do you have the shield? Are you above it? Etc. This is the custom herd boss code. Clear all the sprites, disable the sprites. They kind of technically are the same thing. I must have had a reason at some point for both of them. Clear all the entities. Convert the levels of tile map. This takes the compressed format and just builds it out to an actual collidable map. Is that exciting? Add shadows. Do not look at this function. Just your life's not worth it. Basic collision. Is this a wall? Safe to change it. Yeah, this is the function. Don't bother. This is just a simple lot that converts the. Because I made a tool for editing the levels, and the tool has to define certain concepts, and the game engine has different concepts, and this just converts between the two. How we set a tile onto the map, just I can individually plot tiles because you got to be able to collect things, and walls disappear, and kinds of things. A long explanation for why this magic number is magic. And does the tile. Hey, isn't Vera so much fun? Look at all this. Basic scanning routine. This is the same as the C64 one, but I ported it to use NES spec. That's basically what we can use at the moment. It just shifts out, does a bunch of patch ups. This also generates some events. Joy up event and the joy fire event. So I know when you first press up and I know when you first press the fire button. These are the collision boxes, so if you're having a hard time, you might want to shrink these numbers down, make it a bit easier to sneak past things. Convert X single by entity X. This was a fancy trick I was pulling on the 64 to keep everything to drop the 9 bits down to 8 bits, and it's completely unnecessary on the CX16, so it's all been deleted. Which is nice. Here's the collision system. You can see it's called New Collision because I rewrote it at some point. Very original name. Always works. This basically just shifts to the 4 points, figures out what tile is at those 4 points, and then does a bunch of checks on each of the 4. Sometimes it only checks the 2 left, sometimes it checks the two left and the 2 bottom, the 2 up and the 2 right, etc., etc. It has a bunch of different pointed checks. Clip Y is a fun function. It probably ultimately needs to be changed for the CX16, but it wasn't causing too many problems, so I've kind of left it. Check sprite to char collision. This goes through and makes sure if something hits a wall, or you hit a pickup or something. Collect sprite to char collision Y. This does up and down Y checks and X. The way I do it is I see if you can shift in the, if you want to, shifting the X, you can move in the X, and then you can move in the Y. What this does is, when you have a gap of one tile and you're falling really quickly, it'll be hard to sort of slide in, which you'll miss the point. This way it checks to see if you can go crossways in the X first, and then if you can, you'll move in the X, and then you'll fall down. So this way, if there is a ledge you can stand on, you will slide in and hit and land on the ledge. If you do Y then X, you can miss the gap. This also means you can kind of slightly dig into the wall if you get it just on the right frame. Thought about fixing it, but it turned out to be really handy in the game because you can kind of just duck into a wall and slide underneath something. I left it in as a feature. Check on this tile, this is a dissolving tile. It just checks you're standing on it and then starts animating the dissolving tile underneath you. Slight engine limit. If you keep switching between two tiles, it keeps resetting the timer. The timer is not per tile, but global. And this is the I've just collided with special thing table and function. So if you hit fruit, I clear it, I give you the score for the fruit, you play the collect sound effect. If it's a flower, I see if you've got 8, and if you do, you get another life. If it's a key, I have to check to make sure you've got all of the keys, and sometimes keys clear part of the level. So it scans through and finds all of those. If you hit a spike, you're dead. If you get a spring, unlock the floating power up. If you get a potion, it turns all the spikes into fruit. If you get the shield, I mean, it functionally works, but you can see here I have a timer for the CIA. It doesn't work on the Vera. I haven't bothered to port it because basically it flashes you, which I haven't bothered to port. But on the C64, I used a 32-bit because I bolted the two timers together and made it fire an NMI. Really convenient way to take care of it that you can't do on the CX16. Exit, the eggs. You have two bullets. You have the green one, which will bounce around, which will remove an enemy for a short period of time, and then they'll come back angry and move twice as fast. Whereas the egg will actually permanently remove them. Door animation, it just plots a tile over it. And then here's the fancy, horrible self-mod play sound effect. I mean, the code is here. Obviously, it doesn't make any noise at all, but I've left it in so you can see where I would do a sound effect play, how it works, etc. Play music also is in. It just returns. Oh, this just goes through and sees how many of a certain tile is on the map. That's for when I do the clear all of these type things. Clear the tiles, remove all tiles of, award score. I don't use BCD or anything, I just manually add and compare and see if you're over 10 and then just subtract 10 and set the carry. There's the score tables if you want to change those. Just general conversion functions. Sometimes I need to go from a tile map index to the screen. Sometimes I need to go from the screen to a tile index or to a sprite, or from a sprite back. The basic collision function, just saying, can I stand on this? This draws the status area. Bunch of fancy little tables down below. Draws the score, the high score, the lives, flowers, etc. Sets the player to the spawn point. Tick downs. What I like to do in my engines is I just have a bunch of counters. You'll always have counters for things, and I just group them together into a single struct or section. And this just automatically goes through and counts them all down to 0 for me. And that way if I need a new timer, I just add it to that section and forget about it. This just handles it for me. So the entity system. This is just unpacking the data. Not very exciting. Complicated though. There's lots of special boss handling. Because the bosses are a complete hack job. They use 4 entities for the 4 different pieces. But the first one kind of takes control of the next three, which is a bit hacky. And then also to do the death collision is the first sprite, the bounce on top of the head's the second sprite's collision point. So I use the two different entities to do the two different collision points. It's a glorious hack job. There's two different bosses. There's the octopus and the bear, and they have slightly different setups, of course. Bear body, etc. Yeah. Alright, so here you have a case where I've done LDA, SDA, X, JSR this function, INX, LDA, SDA. This is, I mean, kind of pointless to do, because you can just +1, +2, +3, etc. But keeping the SDA with same thing, X, JSR same thing, and then INX and then LDA is great for compression, and I was getting tight, so that's why the code's a bit too verbose. Again, the bosses are supposed to flash when you jump on them. Not handling. Again, you'd have to do a separate palette, but the trick is some screens have two bosses on them, so you'd have to keep track of which bosses got which palette and update the right palette, etc. Otherwise, that'll all flash, etc. Building collision table. It just walks through all the entities. So the first entity versus all the entities after it, the second, after that one, the third, the fourth, the fifth, the sixth, and the fourth collide against the fifth, the sixth, the seventh, etc. and just goes through. Eats a ton of CPU time, but I mean, there was no risk on the C64. There's going to be absolutely no risk on the CX16. The general update, this just goes through every entity and says, are you alive? Gets its state. Has its movement timer counted down? Is its animation timer counted down? And it just calls its movement. So some just have normal movement. For example, the purple entities just go up and down, and the pink snake things just go left and right. So they're just normal. The spring is a special butterfly. The bat is also a special butterfly. The ghost just randomly moves in 4 directions. The spiders sit and wait for when you're near, and they kind of try to jump you. Fish just go up and down. They kind of spin around and wait off the bottom of the screen. So, first you can see the bottom of the screen, you can see him sitting down waiting. The circular function is an entity that moves in a circle in clockwise, anti-clockwise direction, I think, from memory. And then we got the boss, and then there's the special bubbles, which are another glorious hack job. So, this just goes through, and then if it's going right, checks right and does its normal collision. I use pointer 1 that allows me to jump into these collision functions. So normal movement then does handle ent collision result for the pointer. Then other ones will need to do ent up, right, or down, and then jump back into their logic. So there's a pointer. Effectively, it's a callback for them. So the fish custom function, it waits, it goes up, it has a sign table for its jump. Which it's easy to use an actual sign table and try and get the accumulators just right. The spider function, it checks when the player's near it and it kind of looks at you. It starts to wiggle when it's ready to drop. It has logic to detect the wiggle starts. And it just drop it, either goes to the bottom of the screen or until it hits something, either another enemy or a tile. Then it slowly clinks back up. Circular function, it just moves in a circle. It doesn't care what's in its way. It just moves. There's a fancy, I think I got a quarter jump table and I kind of mirror my way through it. Save from space. Springs. Yeah, springs are a bit special. They use the Y accumulator to jump around. Actually, do they use? I think they use Y accumulator. No, they use the sign table. No, they have a special sign table. So the springs, they are also using the sign table, the same sign table as the fish. That's how they bounce around, but they also move on the X, Y, and they have a lot of extra collision needs because they move quite fast. And also, they're a slightly taller sprite. They are the full 20. Well, they can be the full 21 high. So special collision code for them as well. The ghost, it just moves in a diagonal, and then when it hits a wall, it reflects on the direction it hits. So there's a bunch of extra collision checks to try and figure out which way it needs to bounce. Apart from that, it's pretty straightforward. The bats, they just walk along. As soon as they can't stand anything more, they just fall off. And if they hit something they can't walk through, they just turn around. So they have lots of on-ground detection code the others don't care about. Bubbles, they just spawn and they rise to the top, and then they go into a pool. There's a general pool. Because I had the multiplexer and I'm limited to 32 sprites, I have a maximum number of bubbles that can appear, so the spawning points, the little pipes, have a timer, and when the timer runs out, they say, is there a free sprite I can use? And if so, they spawn, and if not, they just reset the timer and go again. I don't think that actually happens in any levels. I think there's enough slots and spots for all of them to fire whenever they want to, but there might be a couple of cases where they can't. Animation updates code. The third one of these. Special bubble logic. The glorious, horrible, rushed boss code. The boss explosion is 4 of the bullet explosion splat sprites. Because, yeah, time. Also, the bosses look at you. So the upper half will look at you, depending on if you're close enough. There's a bunch of detect where the player is code here. Yeah, and so this is the collision code for the bullets and the player against things. So we have a bunch of special indexes where we jump into various spots in the collision table. Everything is just an AABB check, 2 points. I don't get fancy and do the point to box check because everything needs to kind of collide against itself as well. Most of the time you don't care if an entity hits each other, but in this game entities hitting each other has to have an effect. So I just do AABB. String plotting code. Yeah, this is the multiplexer, which was originally obviously on the interrupt and had multiple interrupts. Now it just blats all the sprites. Well, it blats 32 sprites, not all of them, but just there's a multiplexer. That's it, the whole thing. It's just copies data, copies more data. This just draws the transition screen. Nothing too exciting. Here's the map. Here's all the direction tables. So obviously the helicopters only go up and down. So when what the code does is when you hits one direction, it looks to say, okay, I'm going down. What do I do next? So when it hits 3, it goes to 1, and when it hits 1, it goes to 3. Not all the mappings are correct, so they move around a bit, and that's why I've just got the other sets. The other sets are just the spring, for example, it doesn't use the next direction system at all. Worms, left, right, left, right. Bats, they use left and right, and then they fall down if there's a hole. Ghosts go through all 4, but I have special code to switch that into being diagonal. Spiders, up and down. Fish and the flying things don't use it. The flying thing is the circular entity, I don't know what it's called. Just the base sprites for the direction. So the heli, for example, it doesn't have unique directional sprites at all. The springs don't. Worms do. 52 and 48, so left and right, etc. Frame counters, the sign jump table. circular jump table. Well, it's not actually a jump table, but it's just a circular pattern. It's a bit lo-fi, could really be do with being smooth, but doubling this table eats a lot more space. I can get rid of those. We don't use the colors commented out. But this is the lines for the status panel. So I just go through these tiles and just plot them. Here's the password system. If you're curious how that works, there's a lot of fancy bit shifting to try and hide some values, convert them into letters, and then convert from letters back into values. Crack the password. It also compares, and it actually has a validation system. You can't just type in any letters. It will detect if you've entered a fake password. This is just where the Vera, that's the Vera port section. That's where it pulls in all its data. The title screen data is just the sprites, the strings. So for instance, I want this string at this X and this Y. And they all get pulled together. And then I just pull out all the individual things. Except for the game over screen, because now in this version, I have to put it on the different screen. So I had to pull it out from this version because it has the game screen, not the title screen. That's all. So it's just tacked on. The comma here is an important trick. If you don't have the comma, it doesn't see it as a list or a tuple. Or do something completely different. Sprite colors. Actually, I'm surprised that's being referenced. Be removed. Here's all the strings. If you want to change the strings. Here's the passwords. If you want to cheat. These are the levels that have bosses on them. Here's the sound effect table, which obviously is useless in this version, but you can see how it worked. Here's the big set of chars. Here's the wall chars index. So I can, back chars 1, 2, 3. So I know where to. I have a table I can just index into. This is graphics set 3. Then I just index into it and start copying. The fixed chars for copying, the ver files. This is the file to actual chars table. It's mostly just tile 0 is 0, 1, 2, 3, and then tile 1 is 4, 5, 6, 7, etc. times 4. But when we get to the door frames, they will compress down the saved tiles. Adding these is a lot better than adding 4 tiles. And then when we get to the drop shadows, yeah, it's all magic cookie stuff. I had to sit here and completely redo the shadow system. I've probably made mistakes, but it's just for instructional purposes. Here's all the level data in a binary file, nice and conveniently. And then we have the audio data, which is completely empty. And that's the whole product, basically. So how you get it to build and run? So building, you need 64 tasks. It's available on everything, Amiga 500, everything. It is really pure ANSI. So it's really easy to compile. He has a bunch of pre-built exes, else, etc., DOS. Maybe not on Mac, because Macs are really hard to generate for, but it should be very easy for you to compile. If you can't get it working on Mac, let me know. I should be able to build one for you. I recommend putting it on your path somewhere, just because it's a compiler. You'll use it quite often, and you just constantly change it with the new version. Unlike, say, the emulator, where you need to keep a few versions around just in case. So it has these built-in derivatives. It's all mentioned in the help in the bottom. But, source file, we do .o to the out file. I recommend no caret diag for editing and relaunch. It just cleans it up a bit, makes it a bit easier to use inside relaunch. And obviously you want a labels file. And you want verbose all the way. Line numbers. I have W intermediate enabled. What that does is if you accidentally say do LDA $12 and you don't want to read the value that's inside the memory location 12, you meant LDA hash 12. And that's a really common bug I fall into. And so what this will do is say, you've just put a hex digit that's not a label and there's no hash. Are you sure? Because more often than not, you've done the wrong thing. We have to do -A because 64 TAS is evolution of Turbo Macro Pro, which was actually running on the COM64. So it defaults to reading things in PETSCII. We have to do -A to tell it actually we're in ASCII. And --M W65CO2 because we're in 65CO2. You can specify it inside each ASM file, but I figured it's best to put it on build, one less thing to forget. Don't worry, I have these inside the README MD on GitHub, so don't try and copy and paste it from this video, for example. And then to run it, it's the same thing. You want to do this command, R64-IW, that says ignore warnings. So if task puts out any warnings, it won't continue the script, which is generally not what you want. So this says, if I get a warning, I don't care, run it anyway. And then you get your path to your emulator. I generally don't put these on my path because they change quite often. Sometimes I need to go through and choose a very specific emulator due to bugs or whatever. PRG, the out file, run, debug, and I have Joy1 Nest set. Changes you need. This puts it on F5. It does also have another key on F6, but on Windows, F6 does something else by default in Java, so they put it on F7. However, it's Control F6 still to choose what it is. It is idiosyncratic. But, just F5. As you can see over here, we have the log. It builds, shows you all the files, how big it is. It spawns off screen, of course, but yeah. Other notes for testing. So yeah, if I was doing this properly, I would actually shift the screen down a few char rows to center it, and then I would black out the top and the bottom. This would solve the sprite up the top problem a lot easier, and it would also fix the things hiding down the bottom. In the different fonts caused me a few problems. Having to switch between char mode and tile mode and char mode and tile mode and having things in multiple places. But just so I could print that text there, for example. Not being able to just change the color of sprites is surprisingly limiting. You don't really think it is, but I run into it a few times. Or being able to just change the color of a tile, for example. That's basically the game. If you have any questions about the code, let me know, and I'll try and answer them somewhere.